Hello, welcome YouTube. Welcome to this video of OpenFOAM Salome FreeCAD. So we are continuing the series, and as you can see here, I have something that's running. Okay, and that is actually the pipe case, the heat exchanger with pipe case, where the geometry is what you see here. Okay, of course it's the tetrahedral mesh version, so it's a little bit quite a fair bit coarser than what you are seeing here. Alright, so it's a coarse mesh, coarse tetrahedral mesh, coarse-ish, and it's running rather steadily over here, as you can see. So we'll just let it run. So at least that test case is working. So I'll just walk you through the test case and show you how I arrive there. So probably you would remember last time I was just exporting some of these meshes from Salome, and exporting some of these meshes from Salome, and I'll go to the let me walk you through and show you what the case is like. The case that is currently running, as you can see, it's there are 6 processes, meaning that I'm running this case in parallel. Of course, the mesh I did was the boundary layer UNV mesh. Okay, and there are a few things that were changed. Okay, first, of course, if you go to CD0 original, alright, you will see all of these actually change. Okay, so oops, wrong one. Want to bring you to this file again. I'm using a I'm editing multiple files in Vim, and these are the commands being used. Okay, BF, BL, BN, BP, and BW. BW is to close. So B stands for buffer, meaning to say it's sort of like a window you're opening. How many windows do you have open? So let's show you how it's done. So VI, and then you just put star. That will allow you to edit every single file here. So now I have 7 files open. If you want to see what files that are open, you just press :ls. Okay, :ls, you will see that you are editing epsilon now, and your cursor is on line 15. The rest K, new T, new tilde, omega, P, and U, they are open, but they're not currently being edited by you. Okay, so if you take a look here, you will see that the boundary field is pretty much the same for this epsilon here. Outlet and inlet are the same. Then the rest of the things, the insulated tubing, hot side and cold side tubing, all the same. So to close, I'll just BW, :BW, and now I'm on K, and you'll see that again these are all calculated. I'm using the Spala-Almaraz model, so all these are calculated, no problem. Okay, you have your insulated tubing here and your inlet over here. So all these are calculated, mind you, so don't have to really worry too much. Okay, and again, same with the velocity. Outlet is 0 gradient, inlet is the flow rate inlet velocity, and I'm not going to put the cyclic AMI boundary condition just yet. That will wait. Okay, so I just want to get a rough case running. Okay, so this is the pressure fields. So this will be 0 gradient at the walls and the inlet, fixed value of 0 at the outlet. So I'll just do :BW to close, and this is the omega. Okay, if you're using K omega SST or K omega model or the IDDES models or such, you'll have these fields, but since I'm using Spala-Almaraz, they'll all be calculated. Okay, so here is where you see new tilde. New tilde is the very important one. It is the Spala-Almaraz variable, and describes the amount of model turbulence there is. Again, outlets is 0 gradient. At the walls, it should be 0. Okay, at the walls it should be 0. Or of course you can use a new TU wall function, but we'll just leave it 0 at the walls. okay, and inlet will be the internal field, okay, which is this value I prescribe here. Not physically rigorous and correct, but you know, the syntax is there for you to meddle around with. All right, for nu t, which is the turbulence viscosity, outlet and inlet are the same. You don't have anything there. These are just calculated, but at the walls you have to have this nu t wall function there. Okay, otherwise nothing too much, and that is it. When you're done, just press QA exclamation mark, and all the files will be gone through. Okay, so what else is there? Well, you have to do the meshing part. So go to constant, go to polymesh, and what will you see here? What the difference is? You will see that the boundaries are different, and of course I use a change dictionary to change the hot side tubing, insulated tubing, and cold side tubing all to wall. Okay, the mesh type is wall. Alright, and what is next? Okay, go to system. Okay, of course control dict I didn't really change much. In fact, I should be changing the functions over here. If not, I will run into an error at 0.4 seconds, but that's okay. Okay, so this thing, it looks pretty stable. So the mesh looks good. Okay, it's stable. Okay, so yeah, doesn't really need too much attention in that sense. The next thing is of course change dictionary. So that changes all the patch types here to wall. Nothing too much there. Everything else is more or less the same. I didn't change anything else. It's just the geometry and boundary conditions. All the rest of the things are the same. Okay, so as you can see here, the delta T is about 1.1 times 10 to the minus 5, and it's actually quite stable. Okay, it's actually quite stable. It actually went down to about 1.1 times 10 to the minus 6. Then now it's coming back up to minus 5, and it's there'll probably be some oscillations up and down here, but there's nothing too much to be concerned about, if I'm not wrong. Okay, as long as it's not blowing up. Now it's back to minus 6, and it goes down. Okay, oh, maybe, well, we shall have to see if this thing actually blows up. Okay, because from the way it looks, the delta T is getting really small. 6.7, 6.5, 6.5, 6.4. Alright. Oh well, it may or may not work. Stability is not guaranteed, especially with these tetrahedral meshes. So fingers crossed. We shall see how much this goes. Okay, you look at this. Now the delta T is increasing again. So it looks like there is some oscillatory behavior here, but there's nothing too out of the norm, I hope. Alright, so that's what the files are like. Okay, that's what the files are like. Of course, we may want something similar, so I'll just quickly go through how we edit the files, the appropriate files. Okay, I will change directory, of course, to this directory. All right, and we can, okay, we know that we have the mesh bl tet find.unv. So if we do ideas unv to foam, we can do this bl find unv. This is about 600,000 cells. Okay, so I can run check mesh once this is done. Okay, check mesh, see how many cells there are. So look at this, it's actually about 800,000 cells. So we can do a PolyDualMesh 75 override. Okay, I won't do override because I'm making a polyhedral mesh here. So it's going to do all of this, and I can run check mesh again. Okay, so this is the feature angle. I will tell you what that is shortly. Okay, so it's going to check all the mesh, and it says it failed one mesh check. Say errors in face pyramids. 2515 faces are incorrectly oriented. Why are they incorrectly oriented? Well, we can do something shortly. So I'm going to do touch PolyDual head exchanger.foam. Alright, and now I'm going to open this up in ParaView. Okay, so I'm going to open this up and show you what the PolyDualMesh is like. And of course, you will notice something interesting. Okay, something interesting here. It's the number of cells has dramatically decreased from about 800,000 to 300,000 now. So that's what PolyDualMesh does. It reduces the number of cells by a lot, and this is a fine mesh. To be mindful. Okay, so let's go. Okay, I will do this cold side tubing, just so you know. So this is what PolyDualMesh does, and you can see the cells here. They follow this sharp angle. They call it a feature very closely, which is good. However, they may result in a very awkwardly angled cell over here, because if you think about it, the cells here are kind of convex. If you see this thing here. Now the feature angle of 75 means any bend in the shape that's more than 75 degrees, that will get captured as a feature, and OpenFOAM will try to bend sharply to accommodate. It will deform the cell very abruptly to follow the shape. Now let's say I shift that feature angle to 180 degrees, just for demonstration purposes. Okay, I'm going to do that. PolyDualMesh 180, and let's show you what happens near that boundary there. Okay, so what this does is that it will kind of say, okay, any bend less than 180 degrees, that won't be counted as a feature, and it won't be snapped on as tightly. So what do I mean by that? Okay, watch this very sharp angle here. I'm going to press F5 and it will reload. And look at this. Now you see that these angles here aren't as well adhered to. I mean, overall it doesn't affect the shape too much. It's not very big, not a very bothersome thing if your mesh is fine enough. Okay, so of course in FreeCAD you can actually make some adjustments over here to sort of chamfer or what have you, to make the angle much smoother, much easier to accommodate. But that's another video for another time. Okay, this doesn't really affect the rest of the mesh too much. It just affects the sharp bends and corners. So that's what feature angle is about. If you do PolyDualMesh at 120, okay, you will more or less get the same result. So because this bend here is 90 degrees, okay, this bend there is 90 degrees. Okay, so if I do 120, I will still get the same check mesh, and that check mesh is actually, it's the same kind of mesh, the same features, and you will find that it's exactly the same shape, because there are no really sharp angles, okay, that are more than 120, because this is a 90 degree. So you can see all these sharp edges are still captured the same way, or rather they are in the same way not being captured as sharply. But if you look at the check mesh, you will see that the mesh is okay. So what was the difference between the PolyDualMesh of 75 and PolyDualMesh of 120 and 180, you will see that these angles here are not as well captured, and yeah, they're not as well captured. So well, the thing is that over there you may have a few cells that are really oddly shaped, and that's to be expected. Okay, so that's what the PolyDualMesh, the feature angle, does. Okay, so I'll do an all clean, and let me start by running the solo mesh gen. First, I need the ideas UMV to form to execute on the right file. So what's the ideas UMV to form? Is supposed to act on this file here. Okay, so I'm going to go solo mesh gen, and I'm going to paste this here. After that, it's going to scale down your points, transform points. Then I'm going to do a change dictionary. Okay, change dictionary is nothing bad, and I'm going to do PolyDualMesh of 120. I don't want to capture the edges. I want my mesh to be spick and span, in the sense that you know, the edges there, they don't make those weirdly shaped cells. I don't want that there. Okay, so I have a PolyDualMesh there, and it will touch this heat exchanger.foam. So next thing I need to change, okay, I need to do ideas UMV to form of this, so that I can access my PolyMesh file. My PolyMesh file will contain my boundary file. Okay, so I'll go through vi constant polymesh boundary, and all of these will be here. I want to copy the sides, the tubing sides that I'm going to make as wall. I'm going to change it to wall. So I'm going to system change dictionary, and I'm going to paste it here. Alright, so just delete this, okay, delete this, and all of this can sort of just disappear, and all of this I will change to wall. Okay, once this is done, next thing I'll need to do is to start changing my boundary conditions. Okay, CD0 original, VI star. So I'll need to change this entry here. Everything else remains the same. I'm not changing it to cyclic yet. So I'll quickly change this, and I'm going to change the control dictionary as well. So first I'm going to copy this and paste. Cold side tubing, insulated tubing, and hot side tubing. Alright. Okay, so that's done. Okay, my time is kind of up. So let me finish the editing of these files, then I'll go through control dict, then I'll stop. Okay, so let's copy this entry here, because all of these will reflect the wall entries. So right, and I'll do BW to close this file. Okay, so now I'm on the K file, because our object here is K. Insert, and I'll paste this here, and I'll just delete all of this. Right, BW. So next is here. I'm not going to change anything else. I can, but yeah, I'm just going to delete all of these things here. Right, BW. Right, BW. Write BW. Okay, I'm at the P file now, so I'm not changing anything else. Write BW. Okay. Right, BW, and I'm done. Okay, I'll do QA to quit. So that will change pretty much all the files here. And I'll quickly go to Control Dict, and I'll put the patch names here. Okay, right, so let me put this here, and I'll do average wall shear stress. Okay, I'll do it on the cold tubing. Okay, so I'll do cold side tubing to be my only place where I do wall shear stress. Of course, I can do for all of them. Side tubing, and that's it. Alright, so that's all I have for you this video. Thanks for watching. This is roughly how I do my boundary conditions. Okay, so I can do let me just remove the mesh generation parallel and FreeCAD style mesh gen, and let's do quickly see whether it works. So Salon mesh gen is going to run. Then I'm going to do the PolyDualMesh. So it's going to run PolyDualMesh, and of course change dictionary. Okay, let's try running pimple foam, and it should run. Okay, so apparently there's something wrong, but there's probably a syntax error there. So most of it should be okay. It's just dealing with syntax errors. So thanks for watching. I'll see you guys again. I'll talk about correcting this in the next video. Okay, bye.